All right, so here's the second part of 5.3 assignment number 12. So we're going to start at number 12. Let's read it together. Find the absolute extrema. So I want to find the absolute, the greatest y value, the least y value of that function on that interval. So I'm going to start with the table of values. I'm going to put -1 and 3 in that table of values so I don't forget. I'm going to take the derivative. That's -2x plus 3. I want you to notice that there are no restrictions for the derivative. It's all numbers work. Make it equal to 0. So I'm going to add 2x, divide by 2. So 1.5, or 3 over 2, is in that interval. So this is what I've done so far. It'll probably be upside down. Let's see. Yep, it's upside down. All right, so this is what I've done so far. So -1, 3, took the derivative equal to 0, solved it. And now I just have to find the y values that go with it. So remember, the function is x squared plus 3x. So that's what I'm plugging in. So if I plug -1 into here, I get -1 minus 3, that's -4. If I plug 3 into here, I get -9 plus 9, that'd be 0. And if I plugged in 1.5, I get 9 over 4, or 2.25, one or the other. So what's my max and what's my minimum? So my minimum, my lowest y value, sorry, absolute, not local. So my absolute minimum is -4, and my absolute maximum is positive 9 over 4. Done. If you wanted to double 1.5, so that's right here, sorry, 1.5 squared, 1.5, and then if you had to, I know you could calculate it, but I just did it for you. Number 13. The second of two positive numbers is the reciprocal of the first. So x is the first number, and that means 1 over x is the second number. So the first number is x, and then 1 over x is the second one. And it says the sum is a minimum. So I'll just call that m. That's what I got so far. So the first number is x, the second number is the reciprocal, and the sum is a minimum. And then I'm going to solve that. So I'm going to take the derivative. So I'm going to first write it like this before I take the derivative. Then when I take the derivative, I got 1 minus x to the -2. That's the derivative. Then I'm going to make that derivative equal to 0. See if I can find a max or minimum that way. I'm going to add. Now x to the -2 means 1 over x squared. I'm going to add that to the other side. Then I'm going to multiply and take the square root, and I get positive and -1. But in the question it says that they're positive numbers, so I don't want the negative, so just positive 1. Then I'm going to draw a number line. And put positive 1 on the number line for the derivative for m. Here it is, the derivative. If I plug in 1/2, when you do the reciprocal and square the 1/2, that becomes a large number, so it's going to be negative. And then plug in a number bigger than 1. Again, that's the reciprocal, so if you plugged in 100, it'd be 1 over 100 squared. Anyway, that'd be a very small number, so that's going to end up being a positive answer. So from 1, you go decrease, then increase. So at 1 is a minimum. That's what I'm looking for. So the question is, find the two numbers so their sum is a minimum. So if x is 1, the reciprocal of that is also 1. So the two numbers are 1 and 1. almost spelled the word sum correctly. Come on. So 1 and 1 would make the smallest sum. So he said, which one would make the smallest sum? So 1 and 1 would make the smallest sum. Number 14. Number 14 might be a calculator question. So I'll make sure I have that ready. So you're given a function. It certainly looks like a fancy function. My calculator doesn't really care how fancy it looks. So here is the fancy function that describes how a disease spreads. Oh boy, so it's very applicable. X represents the time and day since the sickness started, and f at x represents the number of people who become sick. Alright, use a calculator to help answer the questions below. So, how many people have been sick by the 10th day? How fast was the disease spreading on the 10th day? All kinds of different things. So, I'm going to use my calculator. So before I start answering those questions, let's set this up. So if I want to set this up, let's define it first. So I'm going to clear what I have. So I'm going to press menu, then actions, and then clear it all. And then I'm going to go, I'm going to clear this as well. So go to the graph. I'm going to clear that as well. So everything's clear. Tab. I just want to define that weird looking function. So I'm going to go control divide. I'm going to type in 4,000 and then 1 plus 100 E. E is not on the bottom, by the way. E is not a letter. E is right here. So use that E. That E right there. E to the X. Don't use the alphabet E at the bottom. E. And that's e to the negative 0.5x. All right, so there it is. Now I'm going to use that, and I'm going to go back to calculate, and then I'm just going to calculate what it asks to calculate, so it'll be easier. So how many people became sick by the 10th day? So I'm going to type in F1 parentheses 10. Let me show you. Just that, F1 parentheses 10. Because it's defined as F1 at X, you just type in 10. You don't, makes things a lot easier. It's people, I'm going to round, 2,390. Part B says what rate. So if you're talking rate, it's a derivative. So it says how fast, that's a rate, was the disease spreading on the 10th day. So now I just need to do the derivative. Menu, calculus, derivative at a point. It is x. The value is 10. First derivative because it's the 10th day. And then what you type in is F1 at x. This is a rate, so you can decimals are good. This would be people per day infected. Oop, there it is. So this is a rate. The first one was just not. Part C. Use the maximum function in your calculator to find the maximum point on the derivative. What does the x coordinate represent? What does the y coordinate represent for that? So I'm going to do this. I've never really used this button before. I'm just going to go for it. So anyways, how did I get here? I should tell you. Let's go back. So I went menu, calculus, and maximum. I said function maximum. That's all I did. I'm assuming if I just type in the function, it'll tell me the greatest y value. Boom, done. So let's see if my hopes and dreams are going to be dashed or if this is going to work. Oh, I'm missing one or more arguments. How do I do that with the max? So x goes to infinity. Take it. I wonder what it would do. I'm just kind of, I'll do it a different way in a moment. I'm just trying different ways it might like or may not like. Alright, so I gotta look up how that maximum function works on the calculator. So instead, in terms of the maximum, I'm gonna go to the graph. And there's my graph. I'm gonna expand out. So I want that window. I'm gonna first see if it fit to the data, if that's nice or not nice. Now I'm going to drag this graph a bit. See, I'm trying up here somewhere, it's going to flatten out as a maximum. So up here, it's going to flatten out as a maximum. I think it's 4,000, to be honest. So up here, I'm going to flatten this out and think, what is that value way up there? Sure, I understand it. Come back here. So it says finding a maximum or minimum with a calculator will not be allowed in the AP test. Interesting. So, what is that part C? Maximum or minimum. So what would happen? Let's find it a different way. So let's take the derivative equal to 0 and see what happens. So it says use the maximum to find the minimum or maximum point of the derivative. Now, if I want to find the maximum of the first derivative, I actually have to use the next derivative to do it. So I'm going to move on to the next page as I'm thinking out loud. So I want to find the max of the first derivative. Let's do this. So I want to find the max of the first derivative. So to find a maximum, you take the derivative equal to 0. So I'm going to take the derivative of the derivative and make it equal to 0 and solve. So I can do that on this calculator. So let's try that. The second derivative. Now I'm starting to think, or not. So the second derivative. So I'm going to press the button beside 9 to get the second derivative. So, you know, this one right there, the one to the right of 9. That you just press that. Looks like a TIE fighter there from Star Wars to the right of 9. Then we're going to move here so I can get the second derivative. So this one this one's the second derivative, see the 2's. The variable's x, and then I'm just going to type in f1 at x. Now I'm going to do one more thing too, because I need to solve an equation. So that's the derivative. I want to know when it's equal to 0, but then I didn't type in solve. So I'm going to just type in the word solve. S-O-L-V-E. I know I can spell, so I'm going to go solve, comma x. So if I don't want to do the other thing, because I think it would be a headache the other way, so I just typed in S-O-L-V-E, comma x. Let's see what we got. 9.210. And then, is that a maximum, right? Is that a maximum value? So for the second derivative, 9.210, does that represent a maximum value for the derivative? And then how would I tell that? So the easiest is, let's use this button again and do second derivative. So if I did the second derivative, here, let's go back. Let's go menu, let's go calculus and derivative at a point. And we have x. The value is, I want to pick a number smaller than 9.20, so like 8. And it's the second derivative. And then I just put in f1 at x. Now what I'm doing with the calculator by doing that is I want to know if the answer is positive or negative. So that gives me a positive answer. If I then go back and like plug in 10, that's the number to plug in greater than 9.210. That gives me a negative answer. See, what I'm doing is, did that create a maximum? I was just making sure. And x again represents days. So at 9 point, right? Or people, days, right? X represents days. The time in days, yeah. So 9.210 days. The rate is at the greatest. So how quickly it's spreading? At 9.210, the rate, the first derivative, is at its greatest number. So the higher the number is for the first derivative, that's how fast, in this case, how fast the disease is spreading. And then when the disease was spreading, y equals 5 represents that 500 people per day are catching the disease. So if you plug that in, 9.210, into the so that rate of a rate there, 9.210. What else did they want you to figure out? And then it says, what does the y coordinate represent? So the x coordinate is 9.210. What does the y coordinate represent in that situation? So on the graph of the second derivative, so in other words here, plug in 9.210. Right? No, because that's going to give me 0. So, let me think again. I'm just thinking out loud with you. So when x is that, that's the greatest for the second derivative. What's the y value on the second, on that derivative? I'm doing the second derivative. I need to do the first derivative. Let me see if that gives me what matches with the answer key. So the first derivative, (9.210) see how I'm doing. Yeah. Okay. So I found the x value to be 9.210. So then I plug that into the first derivative to find the y value for the first derivative. So what's the greatest value of the first derivative? And we've used the second derivative to find a maximum, but that x value I plug into the first derivative to find the y value round, and that second number is 500. So we have an x and the y. This is the rate. That's people infected per day. So this is when it was infected per day the fastest. 500 people are catching the disease at that time. so that this is the rate of people in terms of how fast it is spreading, and this is how many people per day is catching it at the greatest rate. A little confusing, right? It's okay. We did it together. All right. How many people have caught the disease when the curve is the steepest? So, when the curve is the steepest, that's that 9.210. So, into the function, I plug in 9.210. So take 9.210 into the function, and you get 2,000. So how many people have caught the disease when the curve, and the answer is 2,000. E, why would the slope of the curve decrease after a period of time? So here's more of a practical one. So eventually it's going to not increase. Eventually the curve is going to flatten, like COVID. It's going to flatten eventually. And why does it flatten? So it will either, the rate of increasing, so two things could happen. The reason it would flatten is because most of the population is infected, or immune. So over time, the rate can't just keep going up, 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 up. So either it's going to flatten out because most of the population is either infected or immune, and so it's going to then flatten out over time because of that. F. When was the rate of the speed of the disease increasing the fastest? So now we need the third derivative. So when was the rate of the spread of the disease increase? So the rate of the rate of the rate. My goodness, I'm getting a headache out of this a little bit too. Oh, here we go. So what I'm looking for now is the third derivative. There's actually a name for the third derivative. It's called the jerk, but we're not going to use that word right now. So the third derivative equal to 0. So let's see if we can do that. So it's the rate of the rate of the rate, the third derivative. So a derivative at a point. Oh, let me go back. Silliness. So solve SOLVE. And what am I solving is the third derivative. So I'm going to go the third derivative. Now, this one allows me to put in any number. So I could put in, it's x, but this one up here is 3. So that's the third derivative. And then type in f1 at x. That's the third derivative equal to 0, comma x. And the negative, well, there's 6.5 or 11.844. And it says there's a warning there. So it's really the first one. 6.576 days in. So it says, when is it increasing the fastest? We already know at 9.210 in terms of that being that. So it's going to be as it's getting there, right? It's not going to be at 11, which is already then, it's already flattened out by then. So what we're looking for is right here. So what do we know about that? That's when the fastest increase of rate of spread occurs. The third derivative. So right now they're fighting to figure out COVID, and they're fighting to find immunization and trying to keep people safe. This is all science and math, right? That's trying to do the best they can if people listen. to stop the spread of the disease and to try to eradicate it with an immunization right before more harm gets done. All right. We're off of 14. 15. 14. That like took a bit of my soul. All right. 15. Sometimes calculus can do that, and it's okay to think and talk it out loud through it. So 15. A rancher plants to fence in 3 sides of a rectangular pasture. All right. So he has 1,200 yards of fencing. So I know 2x plus y is 1,200. What I know is the secondary. The primary is what I'm looking for, which is what's the maximum area. So area is just x times y. So this is what I know. This is what I'm looking for. Too many variables. Get y by itself. So it's 1,200 minus 2x. Come over here. 1,200 minus 2x. That's what y is. Distribute. 1,200x minus 2x squared. Take the derivative to find that maximum. So to take the derivative, no, it's a parabola full, so I know it's a maximum. So it's 1,200 minus 4x. We're finding the vertex ultimately. Equal to 0. So we add 4x and divide by 4. So when x is 300, you're going to have a maximum area. And if x is 300, y is 1,200 minus 2 times 300. So from this, plug in 300 for x, and it's 1,200, take away 600, that's 600. So it would be 300 feet by 600 feet would maximize the area. Next. And then they said, what is does it ask for the maximum area? Let's see. And it says, what is the maximum area? So then I got to multiply it out. So 3 times 6, that's 18, 1, 2, 3, 4 zeros. So it's 180,000. Is it yards? Yards. Why did I think it was feet? I always think it's feet. Yards. Yards squared. This is what it looks like. You got to multiply these two together, and it's yards. So it's 180,000 yards squared. That's the maximum area. 16. Without using a calculator, find the vertical asymptotes, the extremes, and behavior. Then sketch it. So we have f at x equals x squared plus 2, x squared minus 9. So the vertical asymptotes are the zeros of the denominator. So positive and negative 3 are the vertical asymptotes. The end behavior, I'll write as a limit. That's the same as the vertical or the horizontal asymptote. So if we go power over power, the limit as x approaches infinity of f at x. If I go x squared divided by x squared, both positive and negative infinity are going the same way. So the denominator gives me positive and negative 3. If I go power term over power term, that's also as it approaches positive and negative infinity. So both ends are approaching 1. And then to find the extreme, I take the derivative. So that's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom. And then the bottom squared equal to 0. So I know positive and negative 3 are on my number line, but they are not points. So how can I do this a little bit better? I'm going to show you a little trick here. Notice they both have 2x. So I'm going to factor out a 2x. That gives me x squared minus 9 minus x squared minus 2. So that negative belongs to both. So in other words, the x squares eliminate, and you end up with 2x and negative 18. Negative 11. So you end up with negative 22x. Let's see if I did that right. Yep. So negative 22x. So negative 9 subtract 2 is negative 11 times 2. And then the denominator. So if I look at the numerator, what makes the numerator 0? That would be 0. And then we still have positive and negative 3 that are asymptotes. So 0 is the only extreme point because negative 3 and positive 3 are asymptotes. So now plug here into the derivative. The bottom is always positive. So let's say you take the derivative, plug in 4. The bottom is positive. Negative, negative makes positive and positive. Plug in a number between negative 3 and 0. That's negative 1. That's a negative times a negative. So again, it's positive over positive. Plug in positive 1, and you get a negative over a positive. And then plug in like a big number bigger than 3. And again, it's going to be a negative answer. Oh, I'm running out here. So if I plug it in here, it's going to be a negative over a positive. All right. So what's created here at 0 is a maximum. So we have a max at 0. So we have a max at 0. So if I plug 0 in here, I get negative 2/9. So there's a maximum at 0 and negative 2/9. And negative 2/9 is when you plug in 0 back into the function. So then if I put this together, at 3, at negative 3, those are asymptotes. I know the end behavior is 1. So at negative 3 and 3, and at 1, those are my asymptotes. 0 and negative 2/9, that's like right there. That's a maximum. And then we have the rest of our graph. Just a sketch. And then you have it. So you have one turning point there, and we're done. All right, number 16. See if I can get a pen that works here. Number 16. We just said 16. 17. Use graphing adjustments to graph y equals the square root of x minus 2 plus 3. It's not even calculus. So do you know how to graph this? So the parent, what happened from here to here, it's been shifted to the right 2 and up 3. That's it. So normally the points are 0, 0, 1, 1, and 4, 2. That's the square root function parent. So for each one, I'm going to the right 2. And I'm going up 3. That's it. And then just plot these points. So I get 2, 3, at 3, 4, and at 6, 5. So everything's been shifted to the right 2 and up 3. Number 18. All right, we're almost there. 18. Use the intercepts, vertical asymptotes, relative extrema, and end behavior to graph. Don't use a calculator. Of course not. So, intercepts. So to find the x-intercepts, it's the zeros at the top. So negative 1, 0 is an x-intercept. Plug in 0 for x, and you get 1 over 4. So negative 1 is the x. That comes from the top. Plug in 0 for x, and you're left with 1/4. That's the y-intercept. So I found the two intercepts. Vertical asymptotes, take the denominator and factor it. So if I take the denominator and factor it, that is x minus 2 squared. So if I take the denominator, do it. So I just did that so I can get the vertical asymptote. So at 2, and it's even. Now that means even, both ends are going the same way in terms of like around the asymptote. So around the asymptote, they're either both going up or they're both going down, because of the exponent 2. Then it talks about the extreme. So the first derivative is given. So on a number line, what are the critical numbers then? So the zeros at the top, negative 4 makes the top 0. Positive 2 makes the bottom 0. So positive 2 is an asymptote, so I just have to be aware of that when I do the derivative. So both numbers need to be put on my number line, negative 4 and 2. And then pick a number smaller than negative 4 and see what does it happen to the derivative. So let's say I take a number like negative 5. Plug negative 5 into the first derivative. So a negative times a negative is positive 5, take away 4. And then a negative cubed is negative, so put it together and it's a negative sign, less than negative 4. Plug in a number between negative 4 and 2. So I'm going to plug in 0. Plug in 0 and you get a negative on top and you get a negative on the bottom. So that's positive. Plug in a number bigger than 2. And if you plug a number bigger than 2, you get a negative over a positive, which is negative. So at 2, we have a maximum. No, 2 is an asymptote, sorry. So at negative 4, we have a minimum. So at 2 is an asymptote, but at negative 4, it decreases, then increases. So at negative 4, we have a minimum. And then to find what the y value is, negative 4 would be 3 over 36. So negative 4 and 3 over 36. That's the same as 1/12. And then we can graph this. So the end behavior, notice the end behavior is going to 0. See what this is? So the end behavior is going to 0. And we have an asymptote at 2. So let's do that. There's my asymptote at 2. At 0, we have a horizontal asymptote. So I said, hey, what's the end behavior? The bottom is more powerful. So x over x squared. So the end behavior is going to 0. We have negative 1, 0. And we have 0 and a quarter being a maximum. Oh no, 0 and a quarter is a y-intercept. We have negative 4. Right there. And 3. So 3 over 16th. So that's a minimum. Oh, right there. Tough little one. It's negative, right? Is it? Did I get that one wrong? So when you plug in negative 4, it should be negative 3 over 6. So it's just below. Right there. All right, let's put this silliness behind us. It's going to create a little bit of a low point right there. And then remember, the other end goes the same way. And then you put it together. And that low point right there is negative 4 and negative 3 over 36. So it's barely below the x-axis. Intercept, behavior, behavior. Notice both ends are going the same way, and the ends are going to 0. Putting it all together. All right, number 19. So number 19 says find all the points of inflection. So I want to take the derivative. That's x cubed minus 6x squared plus 2. Take the derivative again. That's 3x squared minus 12x, and then make it equal to 0. So take the derivative, then the derivative again, make it equal to 0. Factor out 3x. Solve it. So 3x gives you 0. X subtract 4 gives you 4. Draw a number line using those for the second derivative. And I need to know there's a sign change. So I'm going to plug it into the factored form. So if you take negative 1 into the second derivative, you get a negative times a negative. So plug in positive 1, and you get a positive times a negative. And then 5 I mean, number bigger than 4. 5 is a positive times a positive. So do you see there's a sign change at 0 and a sign change at 4? So those are my point of inflection. So if there's concavity change and the derivative is fine, there's no restrictions for the second derivative. Here and here are your point of inflections. So at 0 and at 4, and then you find the at 0 and 4, and then you go back to find, so 0 gives me 2. No. I need to go back to the actual function. I didn't even write that down. So 0 gives me negative 6, and if I plug in 4, I'll do the work for you, it gives me negative 62. So those are your points of inflection. So once you find it, you got to go back to the beginning to the function and plug in and do the work to find the y-coordinate. Number 20. Find all extreme points on this graph. So to find the extreme points, the first thing I do is find where the domain restriction is. So I want to find all the extreme points. Here it is. So I factored out in x. So x squared plus 4, there's no 0 there, but there is a 0 here. In fact, I can actually eliminate, and there'd be a hole there. So I can reduce it down. So it'd be 1 over x squared plus 4. The only domain restriction is 0. So now when I take the derivative of that, there's a hole at 0. So when I take the derivative, it's the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom, and the bottom squared. So if I put that together, it's negative 2x, x squared plus 4 squared. Now, what's the critical numbers now? So if I look at the numerator, 0 is a critical number because it makes it 0. And there's no critical numbers on the bottom. Nothing makes the bottom 0. So it's just 0. But we already know 0 is something that it can't be because 0 is a hole. So because this is my only critical number and it's a hole, there are no extreme values. So when I do the critical number, the only critical number is 0. 0 creates a hole, which is not a point. So therefore, there are no extreme values. 21. 21, find the limit as x approaches infinity. That's the right-hand behavior of 2x cubed plus 5. And then 10x cubed plus 6 subtract 3. So that's simply the right-hand behavior of that. And then, so the right-hand behavior is the power divided by the power. So it's 2 over 10, or 1/5. For 22, so again, it's just power over power. So the x cubes divide out, so it's 2 over 10, or 1/5. Again, right-hand behavior. So as x approaches infinity is the right-hand behavior. So again, power over power. This one's 0 because the bottom is more powerful than the top. So again, because the bottom has a greater exponent than the top, it's automatically the right and left-hand behavior is 0. All right, 23, our last one. That makes me happy. Here we go. Makes you happy. Find the C value about the mean value theorem. So let's do this. So y equals negative 3x cubed minus 2x squared plus 3x subtract 5 on the interval negative 2 to 0. And let's go. I will not go slowly. So step number 1, it is continuous and differentiable. It's a polynomial. Both conditions met. Done. Derivative. That would be negative 9x squared minus 4x plus 3. Next, the AROC. So the AROC is this. Y at 0 minus y at negative 2. 0 subtract negative 2. So here, this is the slope formula. So if I plug in 0, I get negative 5. If I plug in negative 2, I get 5. So it's negative 5, subtract 5. So it's negative 10 divided by 2, which is negative 5. So I have negative 9x squared subtract 4x plus 3. That's the I rock equaling the A rock. Make that equal to 0. I'm going to tell you right now, it is not factorable. So what would you do if it's not factorable? Is you use your calculator. Let's do this. So we're going to go and we're going to type in SOLVE. SOLVE. And then we're going to type it in, negative 9x squared, subtract 4x, plus 8, comma x, and let's do it. Oh, equal to 0, silliness. Equal to 0, I didn't get an equation in there, so equal to 0, there you go, you got two answers, but which one is in my interval? From negative 2 to 0. So there's only one in my interval, and that's negative 1.190. The other answer, why did I cross this other answer out? Because my interval is from negative 2 to 0. So this is outside my interval. This is the only one. So the C value of negative 1.190 satisfies the mean value theorem. From negative 2 to 0. So the C value of negative 1.190 satisfies the mean value theorem. And that's it. Done. 5.3. Soul intact. Mr. G Math over and out. Till next time.